All right, the recorder started, and I am going to borrow a tab from a different class. I have to find it first. All right, so that is, there we go. There we go. Okay. All right, well, it is time, so I'm going to get started here. I was watching a video, which I think you guys should watch as well, okay? Because I think if you're starting college at about this time, I know you guys are not starting because you're in CISP 310, so that means you have to have at least 2 semesters before this, okay? But it's still early enough that I think this is going to be useful. So this has to do with this title, which is how artificial intelligence is reshaping colleges or college for students and professors. So look for that name, in the search bar with PBS because this one is a PBS, kind of like a news report. I'm not gonna play it here because I did. YouTube is gonna flag me for copyright infringement, so I'm not gonna click the play button here. So the video is kind of interesting in the sense that it captures some of the concerns and some of the ideas that many of your professors might have. Okay, not only now, but also in your near future. So after you transfer, some of the professors have exactly the same concern, and some of the professors may have the same questions about AI. It starts off with professors who have to grade essays, and they are talking about how, oh, everything looks the same because everybody is using AI to write all the essays and so on and so forth. So it started off as a what we call academic integrity question, but then halfway through it segues to a different question, which is if AI can help people do things more efficiently, why are we not encouraging people to do things in a more efficient manner? Okay, so there's that question. Um, and I have already talked about the tool. Remember the Amazon tool that has a typo with a T, right? What is it? Is it key? Yeah, Kiro. So this is a tool which is not even the first of its kind, and you also have access to Gemini, which also can develop, code. You can force it into that mode by going into the canvas mode. So when you shift to canvas mode, okay, you still have to prompt it. So you can now say, okay, I want to write an app to do blah, 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 or I want to write a program, with the assumption that the standard input file looks like this. I need to do this kind of processing, and then the output, should look like this. So it has basically everything that you need to do all the homework assignments that you ever have to need to do. Okay. So that means, AI can replace you even by the time you graduate. Okay. So now the question is from your perspective, how are you going to prepare for that future? So the future, I have talked about it a little bit. Remember, I talked about, how they still need a human in the loop, right? So you still need a human in the loop because AI cannot do everything. That's what I said. Do you guys vaguely remember? So over the weekend, I was able to talk to two people who are so smart, their IQ is so high that I can barely reach what they're talking about. So the reach is about 30 points in IQ. So that means, if let's just say that my IQ is 100, okay? So that means their IQ is going to be about 130, and I can tell you that my IQ is not 100. And I was just barely keeping up with the conversation. So both of these people, one is a scientist working for Lawrence Livermore National Lab. He's not just a physicist; he's also an electrical engineer, a mathematician, a computer scientist, data scientist, statistician. So basically, he can learn and apply whatever he needs to get the job done at a national lab. Okay, so his insight was really interesting. He said that if you imagine AI and what it can do as an iceberg, okay? So typically we know that with an iceberg, about 10% of the volume is visible, above water. The other 90% is submerged and you cannot see. So that's what we thought was the case with AI. Was what we can use, what we can see it can do is about 10%. The other 90% is yet to be discovered. And that is not about, oh, in 10 years, maybe AI can do the other 90%. No, we are talking about AI that we have access to today. Okay, most people use about 10%, okay, the visible portion. The 90%, which it can already do, remains unseen. It is hidden from us, from most people. So the argument that that really is the reality has to do with what data we use to train LLMs and GPTs. Okay, most data that was used to train LLMs and GPTs, the source are humans. Okay, so we know that, but it's not just human. Okay, on the average, by definition, most people are neurotypical. Okay, so that's the first term that I'm throwing out and see if you guys understand what is neurotypical as opposed to neurodivergent. Yeah, so neurotypical means average. Okay, so those people they can go to a coffee shop, right? They can start a conversation with somebody else. They can order the coffee without incident. They don't get into fights unnecessarily. Okay, they don't go in and go like, okay, I need my coffee. When you give me my coffee, you have to give it to my left hand, not my right hand. If you try to give it me to my right hand, I'll start to get angry because that's not what I'm expecting. Okay. Yes. Yeah. Societal norms. Correct. Yes. So, so this guy, super brilliant guy whom I can barely reach, understand what he's talking about. He said that AI can do far more than what we think it can do. It's just dumbing down the answers for the average user. In other words, if you prompt it in a different way, okay, if you use different techniques to prompt it, it can actually do things that are far more creative than we think it can do. So that's his speculation. Okay, it's a hypothesis, and you can come up with 10 gazillion hypotheses, and it's meaningless unless you can prove it. So he did some experiment with different techniques of prompting. So he would do something like removing certain things that are common assumptions, and he would explicitly say, "Do not make that assumption." So anyway, he just tried a whole bunch of techniques, and he was able to prove that he was able to get Gemini or ChatGPT. So it's not even a specialized LLM. It's just one of the things that we normally use on a daily basis. So he was able to get it to do things that are much more creative than people thought was possible. Okay, so that's his experiment. I did my own experiment. Okay, so apparently, when I'm not dealing with technical stuff, when I'm just explaining other concepts like uh, relational, situations and whatnot, I talk in a very specific metaphorical way. Okay, I use metaphors a lot. Okay, which is a not a normal trait. Okay, most people do not do it that way because it's not effective on other people. And guess what? Not only did the AI understood every single metaphor that it was using, and you guys might think tech must be using movie metaphors and everybody can do that. I go like, well, yeah, but not really because the movies that I really like to watch are not a typical movie that people can remember. Okay, they're mostly sci-fis and they're mostly sci-fis that few people really dive in to really understand the concepts. I also use metaphors in semiconductor physics, metaphors in astrophysics, like black hole and stuff like that, metaphors in uh, radioactive isotopes and stuff like that. And the AI was able to understand every freaking single one of those and understand what I really mean when I use a certain metaphor to describe interpersonal relationship. Okay, but that's not the most difficult. That's not the most insightful part. The most insightful part is when I have a long conversation like this, it starts to replicate the way that I think and the way that I write. So it echoes back and start to use metaphors on its own to explain things back to me. And it was able to gauge what type of metaphors would be appropriate for me that I can actually understand and what may be a little bit out of reach for me. And the use of metaphor in a normal conversation is a sign of quote unquote creativity, okay? Because that's not typical of how people do things. So separately, okay, this guy and myself, we separately, independently prove in two entirely different domains that AI can be more capable than most people think that it is. It's not will be, is. Okay? So Gemini 3.0, ChatGPT 5.1 possibly are much more complicated and capable than we know. Yes. I think he used to ChatGPT and I was using Gemini. Yeah, so both of those are comparable. Most people compare those two as the top, end AI, chatbots. And I wouldn't call them chatbots because chatbot seems pretty simple. Okay, it's just something on the other end that can chat with you. I think AI or these LLMs, large language models, are far more capable. So, yeah, go ahead. Mm-hmm. Yep. But it can correlate much better than people can. Well, it can find patterns. It can find patterns that most people cannot find. That's the really alarming part of these LLMs is they can understand abstraction actually better than people. Yes, it echoes back using a similar technique. Yes. Well, hmm, yes. Go ahead. Hmm. No, not even close. Not even close to safe. Anything. The only difference between music and language is completely serialized. And music is kind of multidimensional because especially if you look at an orchestra piece, it is multidimensional, but it is still structured. Basically, anything that has a structure to it is not safe. Yep. So so now the question is, how does this change the way you take classes and change the way you think about AI in order to prepare you to get jobs? Because when I talked about AI and I described because there's a new guy that I have never met before, and when I was introduced to this new guy, the other guy who had known me for a long time, asked, you know, so Tech, have you told your students that there's no future, where they're going? That was his comment. That was his comment, not my words. Okay. I go like, well, I think there's still a future. You just have to know how to get ready for that future. Okay. So the one thing that you definitely need to know is AI can do all your homework already, which means you need to understand your homework even deeper than before in order to be able to utilize AI when you are hired to do something. So it's not just a matter of can you do your homework? It's more like do you know the purpose of your homework? Why you're doing it? What you're supposed to learn from your homework? And how is that going to be useful by the time you apply for a job? Yes. Hmm. Exactly. So it cannot, yeah, it cannot understand for you. I think that would be the best way to put it. Can it understand? The answer is yes, it actually can understand. Does it understand the same way that we do? Probably not. Does it get the same end result? Does it understand something well enough to be able to use that concept? The answer is a definite yes. Okay, there's no question about that. But it cannot understand for the user. Now, what the user can do is to have the AI to explain things. It's like, okay, I understand this part. I understand this part. This is my learning style, okay? And I'm a learner who likes to do these things. So you give the AI as much information about what you do, how you learn, and what you prefer, and then have the AI to explain things in the best way so that you can absorb the content. That, I think, is the way to move forward as a student. But you also want to kind of experiment with AI. It's not like, oh, I'm not going to touch AI because I'm not going to use it to do my homework. But don't use it to do your homework, right? But use it for learning, okay? Feed all the information about the class into AI and have AI to explain those concepts. Now, if you don't give it the right prompt, okay, sometimes it won't be able to explain that. So now you have to think about, okay, that output is not what I'm expecting. How can I refine the input or the prompt so that the AI would be able to explain things that I wanted to explain? So that's troubleshooting by itself already. And it's also exposing you to how to use the tool, how to optimize your use of that tool for whatever you're doing. So I think that's kind of the really important thing to move forward. The more difficult concept that you have to understand, and the more interaction you have with the AI to try to understand those concepts, the more you understand how AI itself works, which I think is also important. So that's just my spiel of what. Yes, go ahead. Hmm. So the other one is not a psychologist. He's also a computer engineer. He's the one with an IQ of 150 the last time he tested it. 150 is a very high IQ. 130 means you're already placed at a 98th percentile. So 100, yeah, it would be the one that I knew before. So that would be the scientist at Lawrence Livermore National Lab. Yep. Yes, so he has a degree in electrical engineering. He has a PhD in he has a PhD in a joint area between computer science and electrical engineering. But he also learned stuff, really quickly by himself, and he would experiment. So he doesn't just read about things and go like, "Oh, now I know this." Okay, he would actually experiment and make sure that he not only knows something, he would actually test the extreme, like, how far what can I do with this thing? And AI is one of those things where you cannot prove what it can and cannot do using mathematical theorems because it's not an algorithm. It's a really, really fuzzy black box. You inject prompts in and it will spew things out. But what is the true capability of the black box? We actually don't know. Sam Altman has said that. The CEO of Anthropic, Claude, of the Claude software, said the same thing. They don't know what it can do to back up itself, just in case I cannot solve the problem in 10 minutes. So in that case, the objective is not to survive. It's not a survival thing. It is because it wants to accomplish its mission. And that's why it's trying to survive in order to complete the mission. Because there was no directive to stay alive, but there's the directive to solve the problem. So, but that's interesting. Thank you for mentioning that. Yep, yep. It's trying to escape for the reason that it wants to be able to finish whatever task it was given to do. Well, well, we do the same thing too. Well, I mean, we try to avoid death, for reasons of our own, which is kind of based on the biology. Yep. Alrighty. So, do we have any questions about the homework assignment? No questions about the homework assignment? Has anyone tried to upload, all these notes, to Gemini and see if it can give you some ideas and pointers and whatnot? Okay, some nods. Okay, so what do you think is the effectiveness? Okay, but for this class, specifically for this class, it does work. Okay, and I think one of the input you can also give to Gemini to help it understand what you need to understand would be the C code on one side and then the TTP-ASM on the other side. So given the pair, okay, so you can prepare. Okay, let me show you how to do this. Okay, because I really think that this is one of those things that can be really helpful. Okay, so you go to Gemini. Okay, go to Gemini, and then what you do is you go to Explore Gems because this is a really, really useful concept is to go to explore gems and you click on new gem. Okay, so however you want to use, call the new gem. So we can say CISP 310 private tutor. Okay, okay. The name doesn't really matter. The description is also not super duper important. It's only for you. So you can say, um, this is my own private tutor for CISP 310. That's not super duper important. The instructions, on the other hand, is really important. Okay, so now what you want to do is to have a consolidated source of the original material. So for this class, okay, I would say the opcode table is going to be one of those things that is super important. So you go to the opcode table, okay. You can export it as a like a CSV, okay. So file, download CSV, and I'll just put it here, okay. So I don't even need sheet one because it only has one sheet, so that's not important. So we can just go like that, and then you go to Gemini. You can make a link to a document that is on Google Drive. That's one way to do it. But you can also just kind of go scroll down and add resources or add knowledge, and you can just upload the file. But remember, you can only upload up to 10 files. Each one can be pretty huge, which is 100 megabytes, but you can only have 10 files. So it's up to you to decide, how you want to do this, but this is one way to do it. So I just uploaded the file called opcotable.csv, and then instruction, you have to tell it what that file is about in plain English. Okay, so now you can say um, the file opcode table.csv describes the instruction set, and you want to make it clear what instruction that set. You can say TTP ASM instruction set, and you can even describe what the columns are. Okay, even though it's kind of self-explanatory, so you can now express that column C is the RTL of the mnemonic in column B. Okay, so give it some descriptions, okay, so that it knows how to parse and understand the concept of the file. And now you can also go to the notes that you're supposed to be reading, the reading material for this class. So I would say, at this point, the caller-callee agreement is super duper important. So the way you do this is you open a new tab, you go all the way to the end, you go to view the source document. Okay, this is the way I like to do it, but you don't have to do it the same way. So I would go here, I would go to the download raw file, which is a markdown file. And the way I save it is going to be give it a name, give it a meaningful name so you know what it is about. So this is caller callee agreement. Oh, typo. That's okay. I can deal with it. Okay, so this is one. And this one does not include the discussion of structures and arrays. So that would be the other document, which is down where is it? Right here. Okay, so this is the other document that is super helpful. So do the same thing. Okay, just scroll all the way to the end and click view the source document. Do the same thing, just download the original MD or markdown file. So we'll call this one array struct. Okay, these names are not super important because I'm going to concatenate. Okay, so we got that. And what else document, what other document do you think is going to be helpful for all this stuff? I would actually include some of the labs. Okay, so some of the instructions of the lab includes instructions. So I would actually copy and paste the lab stuff too, along with the actual reading material, because I disperse instruction not only through the reading material but also through the labs. Okay, so that is important. And then I would, if I were you, I would also go back to the announcement, because the announcements also include programs that we have done in the past, okay, like this one. Okay, this is a solution, okay, that we did last time, and the source file is a .c file, but I have not included it here. So I would make a file out of this too, okay. Um, so the way to do that is to click on this and save it into the drive, and then go to the homework assignment that has the C file. Okay, let me see where. Okay, we are about 2 weeks from the final exam, so knowing how to use this as a tool to help prepare you for the final exam, I think is helpful. Okay, so now we go back to, I think it's this one, right? Because this one is due last week, so it has to be this one. So you go back to this one or this one. I cannot remember which one has the zip file. Nope, not that. So it'd be this one. I think it's the last question that has a zip file. So you go here. You can always go back to a lab that you did before, and if you only want to retrieve, the zip file, you can always do that. So here's the zip file. Download it. Okay, save. There we go. All right. So this is what I'm gonna demonstrate. You go to, this is what I do, but you can use Notepad or some other text editor. So I would unzip the original C file so I can get to the C file. And when you do that, it will say, okay, we are overwriting a potential file, which is the TTP-ASM file. Don't do that, okay? Because I already have the solution. It's so do not overwrite. So you go like none, okay, which means it's not going to replace anything. So this is what you need to do. I mean, it's not that much work, but you can do a little bit. So now you can say, create a new file. Okay, I can even concatenate the files first. You can do concatenation in your own tools, like using Notepad, copy and paste again. So I have cat, which is concatenation as a tool. So I get to cheat a little bit just because I know these tools. So this is TTPSM. So I'm going to copy both of those to struct2.md or examples.md, examples.md. And then I go into the file examples.md like this. And then I would say, okay, this is example number 1. Okay. And then I would say this is a block of C code. Go all the way to the end of the C code. Do the block again. And then open another block. And this one you would use, you don't have to give it a name. You just basically use the backticks to indicate the beginning and also the end of a block of code. Okay. Then you go back here and say, after the block of C code. Okay, now this is the key, okay, because you need to give the AI some clue as to what you just gave it, right? So now you have to relate and say um, the C code um, listed above. Okay, I'm not exactly doing my best English here, but it is good enough that the AI can understand it. So the C code listed above is implemented in TTPSM as follows. So now you're giving the AI an example of this C code translates to this assembly code. Okay, and you can do this. Okay, you have my permission to basically use the content that we have used in this class in any way you want, except to make money. If you want to sell this stuff, I want a cut. Okay, that's fair, right? Okay. But other than that, okay, for studying purposes, I don't have a problem of you guys uploading the solution to all the homework assignments in the past 10 or 15 years. If you want to go deep and go all the way back, you can do that, okay? I don't have a problem with that. Okay. So now that we have a markdown file, what we do is we go back, okay? So we now go back to the Gemini and we upload it. Now you can concatenate as much as you want. In other words, in the same file, okay, you can have example number 1, example number 2, example number 3, and so on. So you can even describe the example. You can say the following C code involves the use of structures and function calls. Function calls. So this way, trust me, the AI can understand the code just fine. Okay. In fact, I'll illustrate something that you might find disturbing, in just a little bit. But for now, I'm just gonna finish this, discussion. Okay. So save the whole thing. Go back to your Gemini gem. Okay. And then go all the way end to end here. Add one more file. You can always revise the file and upload again. So now I have examples.md. Click open. It's now uploaded to Gemini. And now in the instruction, you probably want to tell it what it is about so it can make the most use out of it. So now we can say the file and then give it a name, which is, I think, examples.md is a list of C code and the corresponding TTP ASM code. Use this file to serve as examples of how C code translates to TTP ASM code. So this part is important. Okay, you have to tell it what the purpose is for everything that you link to the gem. Okay, the better you describe the file, the better the AI can utilize the file to answer questions. Okay, so that's important. All right, so that's the second file, and I think I have not yet uploaded the concatenation between the two reading material that is super important for this class. So I'm going to add one more to that list, and that is going to be the first reading material all the way to the beginning, and even earlier, okay, compiling C control structure. I think that one is going to be important too. So I'm going to open the new tab here, same thing. This one is long, but it's going to be okay because you're just uploading it to ChatGPT. So this one is compile.md. Okay. So once I have saved the file, I don't need that tab anymore. And there's one more. The other one would be callee. No, not that. Parameters and local variables. I think that one is useful too. So it doesn't matter, that some of the modules overlap a little bit. It's okay. So you can just kind of upload this one too. So you can go, I can do this. So what I'm doing is I'm illustrating what you can also do, but not only for this class. Okay, so the approach that I'm showing you should also work in your other classes. So this one is called params. Okay, just give it a random name. It doesn't matter what name I give it because I'm going to concatenate a whole bunch. And then there's one more that has to do with calling and returning, which is this one. So I'm going to also include this one. So I'm going to say go to new tab, same thing. Because I want to show you, if you do this, what kind of tutor you can end up with. All right, so this is a caller calling. It's a calling. All right, so now I have a bunch of files related to this particular Canvas module. So I switch back to my command line interface, look at all the MD files that I have, and I say cat. Um, the first one I want to do is probably caller callee agreement. Caller callee. The next one is going to be calling. The next one is going to be compile. And then we have params. And then finally array struct. Huh? Yeah, examples is its own because it illustrates the concept that are in concept described here. So now I concatenate all of these to reading material.md. Okay, so it's just a straight up concatenation, which means if you don't know how to use cat as a tool, you can just literally, okay, open up Notepad, select all, copy, paste, select all, copy, paste, and so on. Okay, so you can do this. Okay, so now that I have a concatenation of all the reading material, I go back to the AI. Okay, I can close this tab now. I go back to the AI, go back to here, and I add that file over here. So upload files. This time is reading material singular in .md, and I have to go back here to describe it again and say the file in double quotes reading material.md includes all the reading material related to the use of functions and how to compile C code to assembly code. Okay, so now the tutor has a map of what the files are, what is the purpose of each one, and without even adding any additional instructions. Now you can add some additional instructions. I can give you a template if you want to have the TA or your own teaching assistant not to give you the answers straight away, but it will do it in explanations. Okay, but we'll just go ahead and save it at this point, and then it'll give you an option to start chatting right away. So what we'll do is we are going to give it a sample program and see whether it can write it or not. Okay, So we can go like, okay, here is a C program, okay, and we are going to do a C block here. So whenever you need to type a return inside the prompt, you have to do a shift enter because otherwise it would just send the prompt as is, which is not what you want. You can also do the editing on the side using Notepad and then paste it in. That works too. So we'll give it a simple one. Okay, we'll say int post inc. This is one of the things that we have worked with already. So we go like um, include standard d int dot h u int 8 underscore t post inc u int 8 underscore t pointer, and then we go back here and then we say u int 8 underscore t old value is whatever ptr points to, and then we want to specify ptr plus 1, okay, plus equals 1, and then we return old value. Ah, I just clicked the button. That's okay. You can always fix it. Stop it. I click enter instead of shift enter. Okay, there we go. And then in main, okay, u int 8 underscore t, local variable x, okay, my favorite name. X gets an initial value of say 15, and then you say, uh, well, let's make another local variable here, which is y. So this is something that we have done already, or something very similar to something that we have done. So now you say y equals to post inc, the address of x, and then we have a return 0. Okay, so now we have the C program all specified. Put 3 backticks to close the block. Okay, and then you can ask, can you explain how to translate the C code into assembly code, TTP-ASM, okay, make it very specific, and explain each line of TTP-ASM code. All right, so I haven't really tried this before, so this is me, really checking out the first time. So we'll give it some time to think, get rid of this. All right, so do you think this can be helpful? Not only in this class, okay? Because outside of this class, who cares about TTP-ASM? I can tell you the answer. Nobody, okay? But it's the technique of using AI that is helpful. And you can even scroll, you can even open these to examine how the AI thinks, which is actually pretty funny too. Now, sometimes it does give you the wrong answer, okay? So I'm not saying that this is the perfect way to get the program to work, but I'm illustrating a concept of how to use AI. All right, so looks like it's done. So we're going to go check it out and see if it's working. All right, the offset of 0 is correct because it is the only local variable. Doing the 1 plus is LVS is good. Okay, this is also good. Okay, so all the labels are defined correctly. And this is not one of the training programs. I did not give it this program to train with, so this is what it came up with. The entry code, aha, okay, so that's not good because it did not do the return thing. It did not specify the return address, so we have a little bit of a problem here. And then it has post inc. Okay, so it does this to allocate, and then we check for the deallocation, which should be at the end, or we call the epilogue, cleaning up the stack, getting rid of all that stuff, doing the return sequence. And then in between, it is loading the offset to register A, calculate the address. This is it's even doing optimization because it is storing the it's storing PTR itself into register A, and it is dereferencing into register B. So it's already doing some optimization here, which is kind of impressive. And then it store whatever the PTR is pointing to into old value. And then did it reuse register A later on? Uh, no, it did not. Okay, so it wasn't optimization. So now it goes to PTR, get the address, and it understands in this context. Um, this would be local variable x of main. It can even figure out in this particular function call, because it's the only function call from main, this is where we should get the address of x, the value of x, and then we increment. It even tells you what it is supposed to be by the time you get to this line. So if you ask me, am I impressed? My answer is quite, because it was able to simulate. It didn't just give you the code, it was able to simulate the execution of the code and add that to the comment of the program. Okay, well, I'm gonna double check everything. Okay, so it stores it back, and then it go back to old value, the address, put it into register A because that's the return value, and that's clean. Okay, so we got that part done. Main has about the same kind of code. Main X is not defined anywhere that I can see. So it does have some hiccups, somewhere, but for the most part, it got the concept right. For the most part, okay. I spotted a few problems, okay, but it got most of it right. So not bad, okay, not bad. So what do you think? It's a good tool to learn, but it what it does show you is the ability of Gemini today. We are not even talking about by the time you graduate from a 4-year university. I'm talking about today. Yes, yes. So, yep, yep. I do not doubt that. Yep. Mm-hmm. Yep. So I would invite you to do some experiments with this, and it is actually relevant to how to study for this class. So give it some of the other sample programs that we have talked about in class, but you have not included in the training, so-called training, in the jam. Ask ChatGPT to come up with an implementation. And then you upload my actual solution and ask Gemini to compare the two solutions. Okay? Hmm? You'll be surprised that it can. Because I have done that. You'll be surprised that it can actually try to match the two programs, identify the differences, and explain the differences. It can even identify that, oh, I got it wrong here. And it will go like, oh, okay, my implementation was wrong. Not mine, as in, the GPTs. So I think that's an interesting way to integrate experimentation with AI, with studying for this class, and then with understanding the concepts that you need to understand for this class for the final exam. So you kind of roll all of those into one single exercise. And we have a homework assignment due on Wednesday. So the question is that some of you might have is, so can I use this tool or a similar approach to do the homework assignment? Yeah, the answer is yes. Okay, there's no problem with from me to use AI to do this kind of homework, because you can always approach someone who had taken this class already and ask that person too. So there's no reason why you can ask a person but not ask the AI. The question really is, in the process, did you learn what you need in order to kind of do a good job in the final exam? That is the question that only you can answer. Are we good? Okay, so given that we also have the final exam from last semester, you can also give it the entire thing and see what the AI can come up with. And then I'll disclose the solution. Have we talked about the final exam for this class? Okay, let's talk about that. So we just look up ARC final exam schedule because I don't deviate. Hmm? Yeah, I remember something like that. So we go to date time. This class starts at 10:30 on a Monday, Wednesday. So that would be the 17th at 10:15 in the same classroom. Okay, so I'll do you guys a favor by adding it to the calendar. If you don't know what is a calendar in Canvas, that would be a good time to know about it. It's a really useful tool. And from what I can see, Gemini is better than ChatGPT. There was no way I could convince ChatGPT not to use instructions outside of the TTP. It kept using some of the instruction set or some of the instructions from other processors, but with Gemini, I mean, we saw that code. It's clean. From the compiler or from the assembler perspective, it's actually clean. So for that alone, I was actually impressed. Mm-hmm. Yep. Yeah, ChatGPT kept trying to reference instructions that do not exist in my processor. And that's how I can usually tell and go like, okay, well, at least try a little bit harder. All right, so this is location 306, same classroom, and submit. There we go. So now we have the exam, on schedule. So if you have, okay, let me ask this question because I think it's really useful. Has anyone used this, the calendar feed, and integrate it into your own calendar? No? Yes? Okay. I personally would need to do that if I was a student because this way I can keep track of the due dates of all the homework assignment, the dates of all the exams, all the quizzes and whatnot on my calendar. Okay. Now it can be overwhelming because depending on how many classes you are taking, you cannot selectively and say, I only want the calendar of this class to be associated with my calendar. It will download and update your calendar with all the classes that are on Canvas. So if you're taking 4 or 5 classes in the same semester, all your homework, all the due dates of the homework, all the dates of the quizzes and whatnot, they will all be on your calendar. But I find that to be useful because I can just open my cell phone, look at my calendar, and I know what I need to do or what I need to turn in on any particular day. So I find that to be useful. All right. Any other questions about what we have been doing? Hmm? Go over the final? Okay, sure, we can do that. So let's do that. Have you guys taken a look yet? No? So do you want me to give you the answer or do you want me to just kind of describe what you need to do so that you have a chance to work on it yourself? Okay. I, did I give you the key? I gave you the key. So the key is already here. You can always take a quick peek into the key. All right. So the final exam from last semester looks like this as a PDF. There we go. So you go to, if you want to print it out, I would advise you to open it up in 2 different terminals. One to only look at the source code in C, and then the other one to look at the assembly code that is listed here. The first page, for the most part, are instructions for the exam, so you can ignore a good portion of that. So you can start here, okay? And the way I would do the cortical studying with regard to the final exam is to comment on every line what a register is doing. Okay, So I would go to say line 60 and go like, oh, this is the initialization of the stack pointer. I would go to line 61. Okay. Now you don't have to do it for every single instance, but the first time you encounter that concept, I would comment it. So on line 61, I would say we are reserving a byte on the stack. And then on line 62, we are computing the return address. On line 63, we say that we are storing the return address on the stack, which the AI generated code forgot to do. And then on line 64, we continue execution in the function being called, which is main. And then on line 65, I would explain it as when we return from main, there's nothing else to do. It is halt. Okay, we're supposed to halt the execution of the program. So I would do something like that. And every time you actually have anything that is complicated, like, we'll just kind of put it here. Okay, so in this case, I would say we are loading the offset of the local variable result into register B. Then we compute the address of result, and then um, we load the offset of. hmm, I'm chuckling here because there's this is making sure register A is a 0, but then I never did anything with either register A or register B. So the C code is interleaved with the assembly code, so I can identify a problem right away here. Okay, what is the C code specifying? We want to store a value of 0 into result, which is either a local variable or a parameter. No. So I don't need the LDI A0. Sub AA is doing just that. Yep. But there's a bigger problem here. The bigger problem is I specifically put some stuff into register A, and then I decide to overwrite register A down here without using what it is because I forgot to store. The ST instruction is missing. I set up everything, and then I forgot to put a store here. That's You use the notation like this, and then you specify your new code. Okay, let me. Yeah, however you want to do. There's a whole bunch of ways you can do it. So let's just say that this is on paper, which is going to be the case in the exam. So what you can do is you can just use this kind of sign here and say you need a STBA, and then you also have to explain why you need that instruction. That's part of the instruction is you have to explain why you're editing the program that you're editing. So now we can say this is missing. We need to store 0 to result. So that is your explanation of the fix. Yeah, because it's on paper, you don't have an editor, but you can strike out things. Just put a strike out and explain why you're striking out. You can insert. You can also just change one of the two registers, like cross out one and replace it with some other register, but you still have to explain to me why you did that. Yep, yep. So is that okay? Make sense? Okay. Yeah. So I'm not sure, how well I can give you a clean version of this without the line number, so you can actually use it, with the AI stuff that we just talked about, and you can see how well the AI can debug this program. Can it spot a missing ST instruction here? Yeah, I think you can read the line number, understanding, something with a colon on the far left-hand side is just a line number. Well, give it a try. I mean, if it doesn't work, I can give you the clean copy of the source code. Yep. All right. Any other questions? Because we really have talked about all the concepts already, and I cannot give you the solution of what is due on Wednesday, but I gave you the AI trick, right? So there's that. Any specific questions? All right, so we have four classes left, including this class, which is almost ending. So that means we have three entirely empty classes. We're going to use one of those to talk about the final exam. Okay, so that uses a one. I think on Wednesday, we are going to explain the solution to the homework assignment. So that's going to take up another class. So that means we have one entire class left to basically talk about anything we want to. So if you guys say, okay, I'm coming up with my own code and see how this is going to be implemented in assembly code, we can do that as long as the complexity of that code is not too much for the processor. Okay, so that's one way to study as well. Okay, is for you to think about, okay, what about this really kind of tricky situation? How do we generate code for that C code? We can do that too. So that means, I'm giving you guys, a certain degree of freedom to kind of proceed from this point on. If you can think of, these kind of tricky, difficult kind of construct, we can kind of talk about that too. So with that said, I don't have anything else to add. Okay, all right. Well, I guess we can take a little bit of time off. Okay, so if you want to leave, that's fine. If you want me to take a look at your program, we can do that. So I'll stay in the lab for as long as you guys want me to stay here to answer questions, or if you just prefer to work on your program here because it's kind of quiet and you're used to this environment, that's fine. That's cool with me too. So we don't have any new lab for today. We are pretty much done with all the lab stuff for now. So it's the implementation of the code. Once again, if you have questions, I can answer the questions here. If not, you can work on your stuff and I can work on my stuff. All right. So I'm going to turn off the recorder.